In this video, we're going to be looking at vectors. We're going to learn some basic definitions about vectors, learn how to represent vectors geometrically, notate vectors, find the magnitude of a vector, determine the linear form of a vector when given the graph a vector when given the linear form, and perform operations with vectors. The first definition we're going to look at is scalar. A scalar is a quantity that only has a magnitude. For example, temperature, speed, and distance. A vector is a quantity that has both a magnitude and a direction. Example, force, a velocity, or a displacement. And you can see my examples that I am given. Now, the word magnitude is used in everyday language, not just math. It means the size or the quantity. For example, the magnitude of the project seemed overwhelming. Vectors can be in 2-dimension, 3-dimension, or even higher. And in this course, we will only be looking at 2-dimensional vectors. Next, we're going to look at some basic information about a vector, the geometric representation and notation. A vector can be represented geometrically by a directed line segment. So we have an initial point and a terminal point. The direction is shown by the arrow. And we name this vector V, or we can name it AB, where A is the initial point, B is the terminal point. Now, when you're typing the notation for vector, that V is bold. But since you can't really write in bold, the way that we notate vectors is one of these ways. I can write the letter V with an arrow above it, or the letter V with a partial arrow above it. Sometimes we just see a line above it. And there are certain type of vectors called unit vectors that we're going to look at that can be notated with this symbol that's called a hat. The magnitude of the vector is the length of the vector. The notation there are 2 vertical lines on either side of your notation for the vector. Since magnitude is a length, it is never negative. Equal vectors have the same magnitude or the same length and direction. They do not have the same initial and terminal points. And we see an example of equal vectors here. Scalar multiplication is when a vector is multiplied by a real number. Multiplying by a positive number will change the vector's magnitude or the length, but not its direction. And multiplying by a negative number will reverse the direction of the vector. In my example that I have drawn here, I have vector V. And you can see vector 2V is twice the length of vector V. And we have vector that's 1/2 V. A negative 2 times V will have the same length as 2V, but the direction is just opposite. Vectors can be graphed on a coordinate grid. Vectors do not have to have their initial point on the origin, like vector U in my graph below. If a vector does have its initial point on the origin, it's called a position vector, like vector V in my graph below. Every point on the coordinate grid has a position vector associated with it, just like every point on a coordinate grid has an ordered pair associated with it. Unit vectors have a magnitude of 1. The unit vector I is along the positive x-axis. The unit vector j is along the positive y-axis. And these unit vectors help us to define other vectors, which we're going to talk more about that later. You can also have unit vectors that do not lie on an axis. And here's an example of a unit vector that does not lie on an axis. Next, we're going to talk about naming a vector algebraically. Suppose we have a vector v from the origin, the point 0, 0, to some point AB. That vector can be represented in any of the following ways. Different textbooks use different forms. Our textbook uses the first form, the linear combination form. So we're going to look at a couple of examples on how to write vectors in terms of I and j. In example 1, you can see that I have drawn in a unit vector. And here I've drawn in 4 unit vectors. Going back to what we talked about earlier with scalar multiplication, I know that I can take that unit vector, multiply it by 4, and get a vector with a length of 4. So this vector that I have written in blue here is 4i. And I can do a similar thing with the vertical vector j. There's the unit vector, and there's the vector multiplied by 3. So that vector can be represented by 4i plus 3j. And there's my answer for problem 2. And you can see with problem 2, my x coordinate was negative, so my scalar was negative for my I vector. I want to talk a little bit more about what this notation means. So looking at problem 1, I have my answer here is 4i plus 3j. So this indicates that vector v is the sum of this blue vector and the red vector. Remember, sum is the answer to an addition problem. So in other words, that vector v is the result of adding that blue vector and that red vector together. Your book goes into more detail about what it means to add vectors geometrically. The magnitude is the length of the vector. In the 2 examples I'm given here, I'm asked to sketch the vector as a position vector and find its magnitude. So for problem 1, we're going to start off with a vector at point 0, 0, and we're going to the point negative 5, 2. So there's the sketch of the vector. And there's my formula for the magnitude. And here I've substituted in a and b. So I get the magnitude to be the square root of 29. For example 2, I'm going to look at this as the point 2, negative 3. So there's my terminal point. There's my vector. Here I've substituted in a and b into my formula to find the magnitude. So the answer is the square root of 13. Next, we're going to look at vectors that are not position vectors. Now remember, a position vector is a vector that has its initial point at the origin. And if you do not have a vector that is like that, its initial point is just some random point, x sub 1, y sub 1. And we're going to say its terminal point is some point x sub 2, y sub 2. Then that vector is equal to the position vector given by this formula. So a couple of things about the formula. First of all, it is on your reference sheet, so you do not have to memorize the formula. And notice that the order of the points matters. There's a difference between going from point 1 to point 2 and starting at point 2 and then going to point 1. In my example, I'm going to let the vector b be given with the initial point, negative 3, 2. And I want to write the vector in terms of I and j. Now, we can use a coordinate grid to help us if we want to, but we don't necessarily have to have that. On your test, there will be a problem like this, and you will be given a grid for you to use if you want to, but the use of the grid will be optional. Here I have vector v drawn. Here I've sketched in the vertical and horizontal vectors that can be used to notate vector v. And there, the sum of the vectors. Next, I want to look at writing this vector using the formula that's given to me on my reference sheet. So what I've done here is I've taken the points A and B and labeled the x and y coordinates. Here I've substituted the numbers into my formula. Next, I simplify. And you can see that I've got the same answer here that I got when I did the problem geometrically.